Welcome to this module. This is actually on the data center networks virtual bridging. Very small piece of virtualization, just the bridging part. And so we will talk about what is a virtual bridge and how do they connect the virtual machines. Then IEEE has a standard. Some other organizations have their own standards, like single root I/O virtualization from some other organization. And then there are actually two Cisco technologies that we'll talk about how to aggregate the bridges and links. So basically make one bridge out of many bridges or make one link out of many links. And then go back to the IEEE standards for those. Think about network. What is a network? A network consists of starting from a NIC. What is a NIC? Network interface card, right? You connect it to a link, and then you connect the links by the bridges to make an L2 network. Then you connect many L2 networks by a router to make an L3 network. And you put that L3 network in a single data center or multiple data center. So the network consists of the host interface, L2 links, L2 bridges, L2 networks, L3 links, L3 routers, L3 networks, blah, blah, blah. And everything has to be virtualized. And there are standards for how to virtualize. So this whole scope of virtualization, I realized after preparing for this class that I could just teach a whole semester class on virtualization and don't have to go to big data or SDN or anything like that. There's so much going on here. So I selected some pieces to talk about. All right. But anyway, so in particular, there is a lot of recent information on host interface virtualization, bridge virtualization, network virtualization, L2 virtualization, and data centers virtualization. And this is all going on in the real world outside there. You go there and everything is being virtualized. And all of this is new. And that's the interesting part. You go to your textbooks on networking, they don't talk about any of it. Because it is so new. All right. So we start with bridges and actually interface today. And I sat down and made my own list of what is going on. So we start with the NIC. There is a lot of components. So basically, first of all, I realized, and this is my original slide, by the way, that there are two things which are happening in the virtualization world. One is partitioning. You take one big thing and divide into pieces. Take one big data center, which we call cloud, and give it to clients, multiple tenants. Partitioning. Second is aggregation. You take several little pieces and make a big one. Okay, because your application is too big. Because you want to make a big data center, you take many little data centers, make a big one. So there are two things which are the two ways to virtualize. One is partitioning. Second is aggregation. We also call that sometimes extension, sometimes interconnection. So for example, when we say Ethernet extension, we are extending the Ethernet from being one room to one city to one world. That is extension. It's same thing as aggregation. And interconnection is, in case of data centers, we call it interconnection, because when we take two data centers and combine them into one, we call it data center interconnection. So those are the words we might use, but there are two things happening. Partitioning, which means dividing into pieces, and aggregation, which means combining. Now there is a confusion here, because when you do partitioning, when you do aggregate, so the thing is, basically, let me first start here. So NIC. For the NIC, there are technologies for that. For the bridges or the switches. By the way, bridges and switches, the words are going to be interchangeable here because the industry doesn't use the word bridge. Industry uses the word switch. IEEE doesn't use the word switch. They use the word bridge. All right. So there is so much literature. When you go to IEEE standards, you find bridges everywhere. But when you go to the companies, you can't find a bridge, you have to buy a switch. And the point is very clear, because the bridge were originally invented were 2 point. You just had a bridge from here to there, just like a bridge. But the switches are no longer 2-port. Actually, very first and few switches were made, they are multi-port. So as soon as they made multi-port, you don't have multi-port bridge. Then the name bridge is meaningless, right? So the switches, there are standards to partition a single switch into pieces are to combine pieces into a big switch. Link, Ethernet itself. VLAN is a technology for partitioning a single Ethernet, and then there are technologies for combining them. Similarly, the L2 network, L2 link and L2 network. All right, you saw the previous slide, L2 link and L2 network. So this is a link and this is a network. You can combine them or partition them using layer 2 itself. Don't have to go to IP. Or you could combine and partition them using layer 3, which means take the help of IP. And their routers. You could have partitioned a router or you can combine the routers. Then you can take the L3 network. You can combine them using L1, which means physical layer. L2 or L3 actually, okay? And then applications themselves could be partitioned or combined. So there is virtualization at every layer, and there is a lot of competition. From every industry, from every organization, and from every company. So let me tell you what is happening. IEEE tries to see that all the solutions for all the virtualization problems are done in IEEE, which means that everything has to be done at layer 2. They don't want a solution which requires IP, layer 3. IETF wants to solve all these problems by what? What layer? Does anybody know IETF? What layer they work on? They don't work on layer 2. IEEE works on layer 2. IETF works on layer 3 and up. Alright? So they have all the solutions that require IP. Otherwise they will be out of business. Right? So you will see layer 2 solution, layer 3 solution. Then when you go to a company like, let's say, solutions here in the NIC, there are 3 companies. Some companies make the chip. Some companies that make the switch. Some companies that make the hypervisor. Right? So they have their own solution. So they have a solution for hypervisor that requires solution is in the hypervisor, because that way a lot of people will buy hypervisor. People who make the chip, they provide the solution in the chip. So you need lots of those chips that do the new solution. And the people who make the switches, their solutions are in the switches because they want you to buy a lot more switches. So there is so much going on, and there are so many solutions that it will take a whole course, semester course, to just work on this problem. And I have to put a stop somewhere. So I am just about to put a stop. But I made this list just to see the whole picture. All right? So you see how much is happening. So there are 2 footnotes here which I should read. All L2, L3 technologies for L2 network partitioning can also be used for higher layers. If you partition L2, then you can partition IP, because IP runs on L2. So if you want to have IP network divided into 2 pieces, you can use obviously the technology which are listed here, L3 partitioning, but you can also use these other ones. All right. First, when I was making the list, I said I got to copy all of this here also. I said no, hold on. This is general. Anything that divides L2 will divide L3 by design. So that I don't have to do it. Second thing is the aggregation technologies, which make big out of small pieces. They are also partitioning technologies, because when you're looking from the server side, see, there is a client side, the tenant, and there is a server. So the client is trying to make an apartment out of a big building, and the homeowner thinks I am just dividing into little apartments. Right? So there is this kind of overlap and confusion. But basically, these technologies which are aggregation could be called partitioning by some other guys looking from the other side. All right. Having said all this, let's cover the first. I think we are going to cover first 3 lines, first 3 rows in this table. By the way, we have covered some other rows here. We have covered Q and Q, we have covered Mac and Mac, PB, BT, we have covered all this row, whole row, 3rd, 4th row we have covered completely. In this row, in the 5th row, we have covered some of that, but the thing is, there is a lot to be done. Let's go to the problem first. Okay. So the problem is that on each server now, you have multiple virtual machines. So these are the virtual machines, right? But you have only one NIC, right? NIC is the interface card. You have only one Ethernet card. So when you want, suppose you create two VMs, now you need two cards. So you create two virtual cards. Now if you need two virtual cards, they have to, somehow the traffic has to be combined to get out on one physical one, so you need a switch. Alright? So somebody came up with this neat idea, VMware, and they designed a virtual switch which is in the hypervisor, and they provide the virtual NICs, vNICs, to each of the VMs, and then they combine the traffic and it goes out the physical NIC and goes out to the outside real switch. So we have a notation. Everything that is virtual, we start with a V. Everything that is physical, we start with a P. So PNIC means physical NIC. P switch means physical switch. PM means physical machine. VM means virtual machine. vSwitch means virtual switch. vNIC means virtual NIC, and so on and so forth. Alright, this will be a standard we will use throughout. Both V and P are lowercase, except in the case of VM, when it is always written in uppercase, for legacy reason. So VM, you can write little v and capital M, but a lot of people will say, what is this? So you write capital V and capital M. Everybody knows the notation now? Right? So we need a virtualization for we need to vNIC and we need the vSwitch, and then this is a PNIC, alright, and so on and so forth. Alright, the names actually are not on this picture because the picture was taken from some place. I have to read out this picture anyway. So, there are three companies, as I said, which work on this space. One is the companies that make the hypervisor. Second is the companies that make the NICs, Intel, VMware, and the companies that make the switch, the Cisco. Each of them have a solution to help you out in this problem. So the VM vendors designed the vSwitch, and so there is a IEEE standardized it. It is called VEB, and I'm going to talk about that in a next slide. Switch vendors, Cisco's, came up with a solution which requires the outside switch to do all the job, and that is called VEPA, VEPA. IEEE standardized that as well. And the Intel guys, the people who prepared the NIC, they came up with a solution which was also standardized, which is called SRIOB. So three solutions for the same problem. Problem is that you have multiple VMs but only one physical stuff. So how do you make multiple virtual stuffs out of virtual NICs out of one physical NIC? So this is IEEE standard, Virtual Edge Bridge, VEB. It is IEEE 802.1 QBG 2012, just last year, it just came out. If you have VMs and you have virtual switch and you have physical switch, and if you want to go from VM1 to VM2, how can you go? One solution is that you just don't have to get out, you just inside, because you are going inside, you could just go from inside. Alright, second solution is that really you should not shortcut anything, you should go to this real switch and get out and come back. Now both have their advantages and disadvantages. So this solution is called VEB. In the VEB solution, the hypervisor takes care of all the problems, and when the traffic is local traffic, it doesn't get out. Each VM has its own memory, and hypervisor has its own memory, which are separate. So if you want to send something from the VM to the hypervisor, it has to be moved from one address space to another address space. First of all, the VM doesn't know that it is running on a VM. Take that for granted. If you write a web server, you cannot write two web servers, one to run on the VM with another VM and one to run on physical machine to so on and so forth, right? So the VM application is doing exactly as it is running on the real machine, which means it has to take the Ethernet packets, put into IP, and send it out to wherever it is going to go, even though it is just next door. Any other question? And that's a good question, but really there is no shortcut here. In fact, the shortcut that we are talking about here, I will show you in a minute, there's a lot of problem with that shortcut, even though this is a shortcut, that you are not getting out and you are just going in. So this is one solution. The second solution is that there is no shortcut, everybody has to go out and come back. Now there is a problem with each of them. So first let's start with VEB. In the VEB switch, it could be in the hypervisor or network interface card. So there are NICs which can implement this, or hypervisor can implement this. And in this case, this switch can learn the addresses. Actually it doesn't have to learn the addresses, it could just know the addresses because it has instantiated the VM. Hypervisor knows everybody, right? So it doesn't have to learn anything. And it may participate in the spanning tree or may not. And an advantage is no need for external switch in many cases. If you have a single machine with all the servers inside it, you don't need to buy a switch outside. This is, by the way, would be called a one-arm switch, if there is such a thing. And there is a PNIC here which I have not shown. P switch is outside. This is the machine, physical machine. I have tried to be consistent in my notation. Dotted lines are virtual, solid lines are physical. Although sometimes I may have forgotten, but I have tried to be consistent. These are all virtual things. This is one physical machine and there is a physical switch. And things which are not necessary I have not shown here. I have not shown the NICs on each virtual machine and I have not shown the physical NIC either because that is not critical here right now. The critical part is that the vSwitch does the short circuit. Alright, so this is all good. You don't need to buy another piece of hardware. But if you are Cisco or switch guy, you will say, no, there is a big problem with that one. You need to buy. And the problem is, first of all, let me tell you what the solution is. Solution is that every traffic should go outside and come back. Now that requires a new standard because by the old standard, you never send the packet that came on your port 1 back to port 1. Right? So the old standards disallow that kind of thing. So now there's a new standard, which is actually the same QBG, which covers both of these, which allows you to send things back to the same port. So now VEPA simply relays the traffic to an external bridge, and this is also called hairpin mode. Returns the local VM back to VEPA, and otherwise other traffic goes out. Now what is the advantage of this? First of all, now you can see what is going on in the network because previously there are two groups. There is a networking group and there is a application group. So there are people who are managing the web servers. They don't know much about networking, they know about web servers. And there are networking guys who don't know much about web service, but they know all about IP, TCP, OSPF, BGP. Alright. Now the problem the networking guys have is that they cannot see the traffic in their network. Right? And they have a policy, which policy says that you cannot go here, you cannot go there, you should not do this. They cannot enforce any of those policies. This mode allows you to have a standard switch, which can have standard policies, and you can see how much traffic is going from VM1 to VM2. Obviously, if you could change this switch inside to do all that work, but that will be a lot of work, and and the second thing is this network guys may not even see that one. So because of that, basically VEPA is a solution which provides visibility, allows policy enforcement, is performance because now your CPU is free, your CPU vSwitch doesn't have to do a lot of work, and management is easier because you are managing this outside switch. Next thing is IEEE standard allows it, and many people do it, that you could do both in the same switch, in the same machine, and you could do them in tandem. So you don't have to have one VEPA, one web. You could have web on a VEPA and a VEPA on a web, and you would have a whole network inside. Of switches. Yeah.
I don't understand this part. That why is it that VEP switch cannot be actually made as well?
But that's a different switch. The thing is, if you make that, okay, hold on. So you're saying that this whole switch could be put into software inside. What you have done is, then you have bought that switch from Cisco. Cisco does sell software switches, by the way. So it's a real normal switch, except that it is not outside, it is inside. Okay? As opposed to then you buy a hypervisor from VMware, and then you put a Cisco switch inside. Yes, you can do that, but that is as good as this picture. VMware doesn't make this switch. See, that's the thing. There is also this ownership issue.
And how do you come up with the open source VEP vSwitch, and then this this is about vSwitch converter.
Fine. See, here's the thing, and confusion will come throughout this thing. That everything that is virtual can be made physical, everything that is hardware can be made in software, and so on and so forth. So the standards try to do the functionalities. And what they do is they define two functionalities. One is VEB, one is VEPA. VEPA says, I'm not going to do anything on this packet. I'm just going to be a simple gatekeeper, pick up here and throw there, pick up here, throw there, pick up there. So this is all I do. That is VEPA. Right? And VEB is looking at everything. Oh, this is going this way. Oh, I put this here. So those are two standards. How do you implement them? Functionality. This is a step for functionality, not packaging.
More of like interest, company's interest.
Well, that is true. But anyway, so the idea is that now you see these solutions right here, two solutions, right? Oh, advantage of VEB is that you don't need the external switch. This is the line. For some cases. What is the disadvantage? You go to the competition, and these are the 4 disadvantages of VEB. All right? I mean, is that clear? That all the advantages of VEPA are the disadvantages of VEB. All the advantages of VEB are the disadvantages of VEPA. VEB is a switch.
Yeah.
VEPA also needs a switch, yeah.
And the VEB do you need a vSwitch, but it is a very simple switch.
vSwitch. Yeah, no, the thing is, you might actually, in a realistic case, you will need vSwitch anyway, because the thing is, not all the traffic is going inside. If anything is going outside, then it has to go 5 different places, right? You cannot put 5 NICs here, so you give it to a switch, and the switch sends it all over.